Hey guys, this is Coach Brian with part 3, page 3 of your final exam review. Questions 10, 11, 12, and 13 are all very similar where they have given you a trigonometric equation and they're asking you to solve it on the interval of 0 to 2 pi. Now remember, 0 and 2 pi, that's just a full circle. So what they're saying is we would like for you to find the answer to this somewhere with a positive answer. Okay, somewhere with a positive answer. It's the same thing as saying between 0 and 360. So if you saw this interval also, it would say it needs to be between 0 and 360. So all three of these have some, at first glance, complex looking trig equations. So what you would want to do is you would want to use, I keep writing cosine instead of cosecant, you would want to use some algebraic tools to simplify these. Again, cannot write cosecant. All right. So the first thing we want to do is we want to recognize that these are two things that are being added. So we've got this kind of chunk and this chunk, okay? They both have their own values. Notice that both of them have a cosecant. So what I can do is I can factor out cosecant from both of these things, and what that leaves me with is square root of 3 plus tangent of theta. So I factored out a cosecant. So essentially what I'm saying here is that this kind of has a value and this kind of has a value that could solve this equation. And so remember, what we've done now is we've kind of split it into factors. And when you have factors, you can just set them equal to 0 and solve. Well, the first one, cosecant, if I set that equal to 0, and if you remember that cosecant, the ratio for that, it's the reciprocal of sine, so it's r over y. There is nowhere that it's going to equal 0. R is always going to be 1 over, so if you ever did get 1 over 0, that would be undefined. That would be undefined. So there's nowhere that that's a solution for that part. So what we need to do then is we need to focus our attention on this guy right here. Square root of 3 plus tangent of theta. And again, we want to try the same strategy. We want to set it equal to 0. So what we would start off doing here is we would subtract square root of 3 from both sides. Tangent of theta equals the square root of 3. Now, remember, tangent as a ratio equals y over x. And if you're thinking about your unit circle, to get an answer of square root of 3, but use your y's and x's are always, they're always some version of square root of 3 over 2 or 1/2, as long as it's not a 45, 45, 90. So the way you would get this particular answer with these options is you would have square root of 3 over 2 over 1/2. Now, one of these, because your answer is negative, one of them has to be negative. One of them has to be negative. So let's think about the places where, let's think about the quadrants where tangent can be negative. Let's think about that. Where can tangent be negative? If all students take calculus, all isn't going to be it, and take isn't going to be it. So I've got to be somewhere in 2 or 4. So let's keep using our context clues here, okay? Let's keep using our context clues. If we're looking for an answer between 0 and 2 pi, I'm thinking we might have 1 in quadrant 2, and we might have 1 in quadrant 4. Now, again, if your y value is square root of 3 over 2. That means it's your height. So if I go up over here, square root of 3 over 2, and I go over here, down, I'm going to change color so down square root of 3 over 2. That means when I draw my triangle, over here I've gone left 1/2, and over here I've gone right 1/2. So both of these situations would fit what I said I needed of tangent being negative square root of 3. The last thing we need to do is say, okay, if these are both true, then what are the angles? What are the angles that make it true? So if a triangle has a side of square root of 3 over 2, that is across from a 60. Okay, if it has a side that's negative square root of 3 over 2, that's across from a 60. Now let's think about this. If we're in quadrant 2, and this angle is 60, we got there by going 120 degrees. And let's think about it like this. If we kept going around to here to where we only had 60 degrees left, that means we got over here to 300 degrees. Now, that's the two places where this is true, but all of our answers are in radians. So if you know your degrees, which we do, we know it's 120 and 300, then you can multiply those by pi over 180. And so what we get when we do some reduction here is we get 2 pi over 3. And when we do some reduction here, we get 5 pi over 3. So our answers are A and D. For 11, it says, what are the solutions of 2 cosine x plus 1? So thankfully, 10 was kind of like the hard one of these. So again, we need to algebraically rearrange this. So what we're going to do for this one, since it's already set to 0, is we're going to move over the 1, and we're going to move over the 2 through subtraction and division. So essentially, what we're looking for is from 0 to 2 pi, where are the two places where cosine equals negative 1/2? Think about it like this. Cosine is your x. And if your x is negative, all students take calculus. It's not going to be negative here or here, so we're looking in quadrants 2 and 3. Now, again, it's our x, which means it's this line right here, negative 1/2. Now, ask yourself, what two triangles would be formed right there? I could go up, or I could go down, and then I could go back to the origin, and there's my two triangles, okay? There's my two triangles. And if the short side is 1/2, that means the long side is square root of 3 over 2, or in this case, negative square root of 3 over 2. And that means that this angle is 60, and this angle is 60. Now, they are both 60, but those are both reference angles. So we need to figure out what they are. You know, in the full circle, we need to figure out what they are. But then we also need to figure out what they are in radians. So similar to what we did on this last one, if I go from 0 over here to where I only have 60 degrees left to get to 180, that means I've gone 120 degrees. Well, thankfully, we just found that one. It was 2 pi over 3. We just did that on the question before. Now, I finish going to 180, and then I go another 60 degrees. So what's 180 plus 60? That's 240 degrees. Okay, think about it like this. 240 240 is double 120. So if I have 2 pi over 3 and I double that, that's 4 pi over 3. So those are the two places that the cosine of x is negative 1/2. For question 12, it says, what are the solutions of 4 times cosine squared theta equals 1? So again, we just need to rearrange this algebraically. The first thing we're going to do is we're going to divide both sides by 4. So we have cosine squared theta equals 1 over 4. Now, we need to get rid of the square, so we're going to find the square root of both sides. Now, when you square root a fraction, you can rewrite it as 2 separate square roots. So to simplify this, the square root of 1 is 1, and the square root of 4 is 2. Square root of positive 4 is 2. Now, we're looking, again, cosine is your x. So we're looking for places where our cosine is positive 1/2. So if all students take calculus and we're looking for a positive cosine, we're not looking here. We're looking in all and calculus. And again, just like the last problem, this is really just the last problem flipped. We're looking for places where the x value, the x, is 1/2. And so to like fully map this out, we would go ahead and put our vertical lines here. Go ahead and draw our triangles from the origin. And if the x is 1/2, that means that the upright, or the y, is square root of 3 over 2. And when you're down the quadrant 4, it's going to be negative square root of 3 over 2. And now we just need to figure out, what are these angles? What are these angles? Well, to be across from square root of 3 over 2 means that the angle is 60 degrees. Okay, the angle is 60 degrees. And if we're in quadrant 1, great, that's easy. 60 degrees in quadrant 1 equals pi over 3. So that's one of our angles right there. That's one of our answers. But to get down here, if this section is pi over 3, that means we have to go all the way around, and that actually brings us to 5 pi over 3. So those should be our two solutions. Let's go look at our choices. We've got C and E. C and E. All right, last question of this style, question 13. We need to start by rearranging it algebraically, just like we've been doing. We've got sine x minus 2 equals 5 sine x. So think about it like this. I need to first get my sine x's together. Okay, I need to get them together. And on this side, I've got 1, and on this side, I've got 5. So what I'm going to do is I'm going to take the lower side, and I'm just going to subtract 1 to move it over, and that leaves me, if I had 5 and I take away 1, that leaves me with 4. And then, to get rid of that 4, I'm going to divide both sides by 4. So I've got sine x equals negative 2 over 4, which can be rewritten as negative 1/2. Now, we've been working with cosine primarily, but sine equals your y. So we need to think about, where are the two places that y, my up and down side of my triangle, could be negative 1/2. So think about it again. All students take calculus. I'm looking for a negative sign in quadrants 3 and 4. So if I go down a half, and that's my y, and I go down a half, and that's my y, I can go ahead and finish these triangles out. Go ahead and finish sketching them out. And I know that r is always 1, r is always 1. And these are, because I know the ratios, these are across from the short side. That means these are 30-degree angles. They're 30-degree angles. But that's just the reference angle. I need to know the actual angle. So if I start at 0 and I go all the way down, I'm at 180, and then I go another 30, that's 210 degrees. And then if I go all the way, almost, this is 360, but I'm 30 away from it, that means I'm over at 330. So I'm at 210 and I'm at 330. 210 and 330. Remember, to convert these, you just multiply them by pi over 180. And so when I reduce that, I get 7 pi over 6. That's option B. I'm going to multiply this by pi over 180. Reduce that, I get 11 pi over 6. That's option D. Those are the two places where sine of the angle is -1/2. 14 we've done in class, but I'll still go over it. It's a projectile motion. It says a tennis ball is hit 0.46 meters above the ground. That's very important because that is our initial height. It's hit at an angle of 38 degrees. That's very important because that's our theta. The ball has an initial velocity of 27 meters per second. That's very important because that's our velocity. Because it's in meters per second, that also lets us know that gravity is going to be -9.8 meters per second squared. And it wants to know the vertical and horizontal distances after 0.6 seconds. And that's very important because that is our time. So we have a lot of given information here. We need to round these things to the nearest thousandth when we're done. So the first thing we're going to do is we're going to start with our horizontal. And it's the easiest one. It's going to be V times T times cosine of the angle. So you can plug this directly in your calculator. 27 times 0.6 times the cosine of 38. And you should get 12.766 feet. And then we need to use our horizontal, our vertical, which is a little more complex. It's VT times sine theta plus 1/2 G times time squared plus your initial height. So again, that looks complex, but we just plug in what we know, and you can put this directly in your calculator. Again, to be safe, overuse parentheses. Overuse parentheses. So I've got 27 times 0.6 times sine 38. I'm going to put my plus sign here, and then I'm going to do 1/2 times -9.8 times, again, I like to put another parenthesis here, 0.6 squared. And then at the very end, don't forget, you've got to add your initial height, 0.46. You can plug that into your calculator just like that, and it should give you that the vertical height was 8.670 feet. All right, that's all for part 3, and I will talk to you in part 4.